Chapter 8 is titled Rational Functions. We're only covering 3 of the lessons in Chapter 8, and it's all about factoring. I thought it would be a great idea to do a little factoring review before we get started. When factoring, you should always check for a common factor first. A common factor is something that's present in all the terms in your expression. If we're asked to factor something like 4x minus 12, there are 2 terms in this expression, the 4x and the 12. A common factor would be something that you could divide out of both of those terms. 4 goes into both 4 and 12. That would be the common factor. What that means is if we factor 4 to the outside of that expression, 4 out of 4x, we would have just an x left over, minus 4 goes into 12 3 times, so we'd have 4 times the product, x minus 3. That would be the factored form for 4x minus 12. Over on the right, we're asked to factor another expression, 2x cubed plus 14x squared. Still, we have 2 terms separated by addition. These terms have both a number and some variables in common. For 2 and 14, they both could be factored by 2. And x cubed and x squared. The biggest factor of x that we could take out of both terms is x squared. Then we have to see what's left in the expression after we take those to the outside. If we factor 2x squared out of 2x cubed, we would have x left over. And if we factor 2x squared out of 14x squared, the x squared cancels out completely for that term, and 2 goes into 14 7 times. It's always important to check for a common factor first. The most popular types of factoring options would be when you have those 3 terms, like a squared term, a non-squared term, and a constant. It says if you have a quadratic term in the form x squared plus bx plus c, notice we don't have a label for the coefficient in front of x squared. That would mean x, the a value for that would just be 1. When it's in this form, we go right to that constant, that c value at the end, and we factor c into 2 numbers that would also add to get the b value in the middle. So here's a couple of examples as review. It says factor x squared minus 9x plus 20. So in this case, a equals 1. And because of that, we can go right to the constant of 20. All possible factors of 20 include 1 times 20, 2 times 10, and 4 times 5. Those are all the ways you could multiply to get 20. But if we want them to also add to get negative 9, we have to think about introducing negative options as well. Well, 1 and 20 wouldn't work, 2 and 10 wouldn't give us that value, but if we make 4 and 5 both negative, they would multiply to get positive 20 and also add to get negative 9. Once you find the pair that does both of those parts, we split up our x squared term into x times x, and the minus 4 and minus 5 follow, and you can write them in either order. That product is the factored form for x squared minus 9x plus 20. The one on the right, kind of same idea. Factor x squared plus 5x minus 6. Again, that lead term, that a value is 1, so that allows us to go right to that c, the negative 6. Numbers that multiply to get 6, we have 1 and 6 and 2 and 3. Now, on this problem, both of those pairs can get you 5 in some way. We have to figure out which pair gives us negative 6 when you multiply and positive 5 when you add. If we did positive 1 and negative 6, well, that won't work. That'd give us negative 5. But if we flip that, if we do negative 1 and positive 6, we would get negative 6 when we multiply and positive 5 when we add. So if I make that 1 negative and the 6 positive, that would work. Unfortunately, 2 and 3 wouldn't work for us. They would either get positive 6 if we wanted positive 5, or we make it negative 1 if we wanted to get negative 6 when we multiplied. So this is going to be the pair we want to go with, the negative 1 and the positive 6. Once we know that pair, again, split your x squared into x times x. Minus 1 and plus 6, again, can go in either order. When we introduce the a value into the equation, you may remember that we multiply a times c, and then split to get that b value in the middle. So this is known as a times c split to get b. One thing to note on these polynomials or these terms is make sure to check for that common factor, because that will affect our factor process moving forward in the problem. For the first term, we have 4x squared plus 1x plus 3. None of them have anything in common with each other where we could take it out of all three terms, so we're good to go for our step process. It says multiply a times c and then split to get b. A is 4, c is negative 3. So if we multiply those two together, we actually get negative 12. Numbers that go into 12 are 1 and 12, 2 and 6, and 3 and 4. So I'm hoping this is kind of sounding familiar to you. We need to figure out how we can multiply two of those numbers to get negative 12 and add them to get positive 1 for the b value. If you thought negative 3 and positive 4, you're good to go. So this is that problem where we just go x minus 3, x plus 4 to start off with, but that's not our final answer. So recall that 4 that's out in front, our a value, we have to actually divide both of those numbers by 4. And 3 divided by 4, since it doesn't simplify, that puts the 4 in front of the x as part of our factored form. And that would give us 4x minus 3. But watch in that second parenthesis, 4 divided by 4 cancels out to be 1, which makes that second parenthesis just x plus 1. This is the factored form for 4x squared plus x minus 3. If you FOILed that and combined like terms, you'd get the original problem. Over on the right, factor 6x squared minus 27x plus 12. Here, if we look for a common factor, we've got 6x squared, 27x, and 12. Here we have a common factor. What number can come out of all three of those coefficients? 6, 27, and 12. We could factor out a 3. And we have to do that first before we multiply our parts together. So if we factor out that 3, let's see what's left over. 3 goes into 6x squared 2 times, so we'd have 2x squared left over. Minus 3 would go into 27 9 times, that would give us 9x, plus 3 goes into 12 4 times. So now this is the polynomial that we do a times c split to get b. We have 2 for our a value and 4 for the c value. 2 times 4 is 8. 8 breaks down into 1 times 8 or 2 times 4. We need to get negative 9 in the middle, so 2 and 4 really aren't going to do us any good. If we make both 8 and 1 negative, that will work to get negative 9 in the middle. So we'll start off with just x minus 1 and x minus 8. Don't forget that 3 out in front. And then we have to think about that lead coefficient that was in the parenthesis of 2. We're going to divide both of those numbers by 2. Since that first number, 1 over 2, doesn't simplify, I'll put 2 in front of that parenthesis, and that would give us 3 times 2x minus 1. In that second parenthesis, though, 2 goes into 8 4 times, making that second parenthesis x minus 4. This is factored completely for 6x squared minus 27x plus 12. Another factoring form is the difference of two perfect squares. If you have a perfect square minus another perfect square, that splits apart into the two parentheses. And oh wow, I didn't give myself any space for that, did I? Can I erase that? There we go. I'm just going to get that out of the way there so that I can write this answer. Whoops. Let's see here. Okay. All right, so I'm just going to underline that. Yeah, that's our final answer there. Okay, here we go. Difference of two perfect squares. If you have something squared minus something squared, it does give you two parentheses. The x squared splits apart into x and x, just like it normally would. And then if the second thing is also squared, that'll split apart into c and c, or whatever those numbers would actually be. In between, you want one positive and one negative so that it cancels out the middle term that would be in the FOIL. All right, let's take a look at our examples and see how that works. We have factor 5x squared minus 20. Like up above, anytime you have that lead coefficient, you want to try to check for a common factor first. They both have a 5 that we could factor out. So just like up above, you want to start there. If we take 5 out of 5x squared minus 20, we would get x squared minus 4. X squared is a perfect square, and 4 is technically a perfect square. That would be 5 times x squared minus 2 squared. When you see it in that form, we can split apart into the two parentheses. X and x, 2 and 2, one's positive and one's negative. That's one of our special factor rules. Over on the right, try another one, m squared plus 16. We have a perfect square with 16, but we actually can't do anything with this problem. It's significant that it's addition in the middle. The rule doesn't apply for addition. So make sure to write that down. The rule doesn't apply with addition. And what that means is that this is not factorable. So be careful. Whoops, not. Let's get to not in there. Be careful on these. They're kind of tricky because it looks like they're perfect squares, so you want to split them up, but you wouldn't get that, or you'd get a term in the middle that actually isn't in the original problem. These are some of the specific factoring rules that we'll cover this semester, or this chapter, but guess what? There are a couple more that I forgot to write on here, so hold tight. Whoa, and just like that, there are the other two formulas that we've seen before that will be applied in this chapter. I don't know why I didn't write them in, because we do use them. Just like perfect squares, we have formulas if we have a sum or difference of two perfect cube values. A cubed plus b cubed or a cubed minus b cubed. Make sure to write this down because we'll see these right out of the gate with our very first lesson. If we have two perfect cubes and they are separated by addition, remember we always split these up into two parentheses, a little one and a big one. So I hope that rings a bell. If we have plus first, we have plus first in that first parenthesis, just a plus b. Then in that second parenthesis, we take the a value and we square it, and then it changes to subtraction. And we take the product of the first term and the second term together. Then it goes back to addition, and then we square that second term. And remember that second parenthesis does not factor any further. We talked about that before. The trade-off with subtraction, all the letters stay the same, but the pluses and minuses change just a little bit. If it starts off with subtraction in the original problem, the first parenthesis is also subtraction. And then it goes a squared, changes to plus ab, and then stays plus b squared. So we're going to use these methods as well. Make sure to keep those as a resource as you work on your assignment.